plot an acceleration time graph for this motion. The acceleration all the time is 10 meters per second squared. So we end up with a straight line with a zero gradient, a flat line. But it's not on the zero line as was the case in uniform velocity. In this case, because the acceleration is always 10 meters per second squared, the straight line is at the 10 meters per second squared level. Let's get the area beneath the graph for these two intervals. First, for the entire interval, 0 to 4 seconds. This is a rectangle, so we can simply calculate the area by area equals length times breadth. What does the area underneath an acceleration time graph tell us? Well, the length is acceleration and the breadth is time. What is acceleration multiplied by time interval? Let's use the units to help us. The unit of acceleration is meters per second squared. The unit of time is seconds. Meters per second squared multiplied by seconds equals meters per second. The area underneath an acceleration time graph tells us the change in velocity for that interval. So let's calculate the area here. The area of this rectangle is 10 meters per second squared multiplied by 4 seconds. If we want to do it the long way round, t final minus t initial, 4 minus 0 is 4 seconds. 10 meters per second squared multiplied by 4 seconds is equal to 40 meters per second. That means that during that interval, the velocity changed 40 meters per second. And that is indeed the case. It started off at 0 meters per second, and at the end of the 4 seconds it was going 40 meters per second. So the change was 40 minus 0, 40 meters per second. Now let's get the area for the interval 1 second to 3 seconds. So we can see that this is a smaller rectangle. Area is equal to length times breadth. The area means the change in velocity, the length is the acceleration, and the breadth is the time duration. We can see that it's 2 seconds long, but let's substitute it into the full equation, t final minus t initial. So the change in velocity is equal to 10 meters per second squared, the acceleration, multiplied by 3 minus 1, in other words, final time 3 seconds, initial time 1 second. 3 minus 1 is 2 seconds, that's the duration of the interval. So we have 10 meters per second squared multiplied by 2 seconds, 20 meters per second. That's how much the velocity changed during this interval. Let's check that. At the start of this interval, the velocity was 10 meters per second. At the end of the interval, 30 meters per second. How much did the velocity change? 30 minus 10, 20 meters per second. Now let's calculate the change in velocity for these two intervals, but using the equations of motion. There are two equations we can use. One is the simple meaning of change of velocity, v final minus v initial, and the other is the calculation delta v is equal to acceleration multiplied by a period of time. For the first interval, 0 to 4 seconds, final velocity 40 meters per second, initial velocity 0 meters per second, 40 minus 0, 40 meters per second change. That's the same as what we found for the area underneath this graph. Let's use method 2, delta v is equal to a delta t. We know that this equation is correct from a rearrangement of the definition of acceleration. Acceleration is the rate of change of velocity, delta v over delta t. So we can rearrange this equation to make delta v the subject of the equation. Delta v is equal to acceleration multiplied by delta t. Delta t is t final minus t initial. Acceleration for this motion is 10 meters per second squared. For this interval, t final is 4 seconds, t initial 0 seconds, so the duration of time 4 minus 0 is 4 seconds. 10 meters per second squared multiplied by 4 seconds is 40 meters per second. We find the same answer with each of these two methods, and it's the same answer as we found when we got the area underneath the graph. B. We must calculate the change of velocity for the interval 1 second to 3 seconds. We first use the simple method v final minus v initial. At the end of this interval, At 3 seconds, the velocity was 30 meters per second. At the start of this interval, in other words, at 1 second, the velocity was 10 meters per second. The change in velocity, 30 minus 10, 20 meters per second. Now let's use this equation, delta V equals A delta T. In other words, delta V equals A, T final minus T initial. Delta V is equal to, acceleration is 10 meters per second squared. The time interval is 3 minus 1 seconds, 2 seconds. 10 meters per second squared multiplied by 2 seconds is 20 meters per second change. So we see that we get the same answer using both of these methods, and it's the same answer that we got when we got the area underneath the graph.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!